We're going to continue on in Unit 2 and talk more about the periodic table. Um, the periodic table contains a ton of information. It may shock you to know how much we can get from the periodic table. This is an example of the periodic table. Oops, I'm gonna. So with this periodic table, it has two sides, and each side contains different information. For you guys, the periodic table in your textbook is perfectly acceptable. You will find it on the inside front cover, and so that's a great place to look at it. Definitely have it handy for quizzes and stuff like that. So we are going to go through and talk about the different properties of things on the periodic table. Let me see. So metals, which can be found on the left side of the periodic table. They also conduct electricity, and they're ductile, meaning you can pull metals out into wire. So you have two types of metals. So you have metals here. You also have a few metals here. And then you have transition metals here. On the right side of the periodic table, you have nonmetals. And the nonmetals can be found here. Oh my goodness, I'm just having all sorts of stuff. Nonmetals can be found here. Then the stair-step area is called the metalloids, or sometimes you'll hear it referred to as semiconductors. So semiconductor. And the specific elements that are considered semiconductors are boron. I'm looking at the periodic table and getting this information. Silicon Valley, germanium, arsenic, antimony, that's SB, and tellurium, and then one more, astatine. Okay, so those metalloids have properties that are similar. They're kind of a mix of metals and nonmetals. So combo of metals and nonmetals. Now, I didn't say nonmetals do not conduct electricity. That's good to know. All right, on the periodic table, groups are up and down, so vertical, while periods are horizontal. Going on to the next page, you can see this. Periods are horizontal. Groups or families are vertical. So I have listed here at the bottom of this page, there are different families. Not every vertical column has a name or family name, kind of like your last name, would be your family name. So the alkaline earth metals, they can be found in group 2. Let me put these numbers here. I'm going to number them this way. 1, 2, 3, 4, 5, 6, 7, 8. Your textbook, the periodic table, has 2 systems of numbering, so it's like 1 through 18 or 1 through 8. This is really the best way to number. So I'm going to refer you to these group numbers when I go through each one of these family names. So alkaline earth metals are group 2, while alkali metals are group 1. Halogens are group 7. Noble gases are group 8. Main group are the ones that I have numbered. Sometimes they have the letter A after them. And let me check your textbook one just to be consistent. Yeah, so the ones, I love that numbering system with 1A. And then the non-main group, this would be like your transition metals, non-main group. So main group has the letter A after it. Transition metals, these are your B groups. And the inner transition metals, it's kind of funny. Inner transition metals can be found on this island off the periodic table. So this is inner transition. Okay, so island off periodic table. So one thing I want you to do is to go through and label the families, groups, periods, and sections we just learned about. So I want you to go through and label this on this blank periodic table. So how I would do this is definitely turn it, well, first I'd number. So 1A, 2A, 3A, 4A, 5A, all the way to 8A. And then I would start with my families. So this is alkali metals. This is alkaline earth metals. In here, transition metals. And then we have inner transition metals. And then we have 3A, 4A, 5A, 6A, 7A is halogens. And then we have noble gases. You can then go ahead and label your metalloids if you want to. A lot of different ways to do this. These are the metalloids or semiconductors. And you can even go so far as to label kind of this side as metals. Sorry, you can't see that. Metals. And then over here, non-metals. So definitely something you want to have memorized. It will make answering questions on quizzes much easier. So, going on to talk about the arrangement of the periodic table. There were several attempts made to arrange the periodic table in a systematic fashion. The most successful arrangement was made by a Russian chemist, and you will find that Russia did a lot for chemistry, Dmitry Mendeleev. So you come across a lot of funny names, and a lot of them are usually Russian. So Mendeleev's periodic table was based on atomic masses. And Mendeleev was so insightful. When he discovered gaps, he attributed them not to some, oh, it just doesn't work out. He attributed them to undiscovered elements. So, very open-minded and looking into the future. So interesting. So, undiscovered elements. The modern periodic table contains, let me see, depends on the ones you're looking at. The one I currently have in your textbook also has, if you look at the highest number, 118 confirmed elements. With this periodic table, and even your periodic table doesn't have abbreviations written for 112 through 118. This periodic table that I have right here, the outline says, so when the letters are outlined, it's hard to see that. That means that, let's see, they're synthetically prepared. So it's not like you could buy this element and it would last. It would definitely be very fleeting and short-lived. So now we're going to talk more about, let me change this a little bit so it's clearer for you guys. Okay, that's better. Recall from Sesame Street, 8 is great. So we're going to talk about electron configurations, and it turns out that electrons have a lot to do with chemistry and predict bonding and a lot of good stuff. So if you remember that 8 is great from Sesame Street, you will go far. So valence electrons are the outermost shell electrons. And the octet rule states that atoms will lose, gain, or share electrons in order to achieve 8 electrons around the atom. Atoms will gain, lose, or share electrons in order to achieve 8. There are some exceptions. Hydrogen just likes 2 electrons. Helium just likes 2 electrons. I always joke around that these are the minimalist elements. They don't want to have more than 2. There's another one, kind of a funny one. Boron only likes to have 6 electrons. So that brings us to ions. So when an atom loses or gains electrons to get 8, it's no longer neutral. It has a charge. So an ion is a charged species. A cation is a positively charged ion. An anion is a negatively charged ion. So a cation is formed by losing electrons. An anion is formed by gaining electrons. So I always tell this cheesy joke because I like cheesy chemistry jokes. So 2 atoms go to a bar. One atom says, I think I lost an electron. And the other atom says, are you sure? And he says, yeah, I'm positive. So losing electrons results in a positive charge. And I always think of positive with that T. Gaining electrons results in a negative charge. And sometimes this is counterintuitive. Like a lot of students get this confused. They always get it flipped around. Think of it like weight. If you gain weight, so you have a huge Thanksgiving or Christmas dinner, gain weight, that could be a negative thing. Maybe you need to gain weight. I don't know. It could be a positive thing. But let's just think of it in a typical application of weight. If you lose weight, that could be positive. So that's how it works for electrons. All right, so we're going to talk about Lewis symbols. So Lewis symbols are electron dot structures, just show valence electrons. And what these were designed to do is to show the bonding. So show how the electrons were bonded to different things. So let's draw the electron dot structures for the following atoms. Okay, so sodium is in group 1. It is an alkaline metal. It just has 1 valence electron. So that's just going to get 1 dot. You can put the dot anywhere around sodium. Magnesium is in group 2. It's an alkaline earth metal. It has 2 dots. Leave them unpaired as long as possible. Aluminum has 3. So it's going to go like this. Nitrogen in group 5. It has 5 valence electrons, so I'm going to go around with 1. So 4 different sides and then pair them up. Oxygen is in group 6. It has 6 valence electrons. Again, leave them unpaired as long as possible and then pair them up. Now your 2 unpaired and 2 paired could be on different sides than mine. That's fine. Bromine has 7 valence electrons. 1 paired and 3 paired. And then neon is a noble gas. Noble gases really don't like to bond with anybody else, and it's because they have a full octet. They're happy, they're content, they don't need anything else. So which atoms above would gain electrons in order to achieve an octet? So not neon, because it has 8. So bromine would be 1, it would just need to gain 1. And then oxygen has 6, so it would need to gain 2. Nitrogen is another one. Nitrogen would need to gain 3. And the ones that would lose electrons, it is true that aluminum could gain 5 electrons, magnesium could gain 6 electrons, sodium could gain 7 electrons, but that takes a lot more energy than losing electrons. So sodium, magnesium, and aluminum are going to lose electrons. So sodium would lose 1, magnesium would lose 2, and then aluminum would lose 3. And the one that would neither gain or lose electrons, that's your noble gas, neon. So label your periodic table with the charges that atoms in each group form. So sodium is going to be +1. Magnesium is going to be +2. Aluminum is going to be +3. And you could write 3 plus or +3, it doesn't matter. So bromide is going to be -1. Oxide is going to be -2. Nitride would be -3. So this gives you an idea for the different charges that each group would form. So group 1 would be +1, group 2 would be +2, group 3 would be +3. Carbon likes to share, so it doesn't form charges. Nitrogen, group 5, that would be -3. Group 6, -2. Group 7, -1. And then noble gases, no charge. Okay, so then I wanted to show you that if you look very closely, it's having trouble focusing, at the transition metals, there are different transition metal charges that can be formed. So some atoms can have 2, 3, or even 4 ions that can be formed. And that concludes our lecture for this portion of Unit 2. Be sure that you practice your Lewis symbols and also practice your charges because this is important later on in chemistry. So until next time, I will see you. Have a great day.